Alright, now one of our named continuous random variables is known as the normal distribution. Normal distribution is our typical bell-shaped curve. It is mound-shaped symmetrical, and the values that you're going to find at 1, 2, and 3 standard deviations away are going to very much reflect what we had with the empirical rule. Now, this bell-shaped is centered with the mean mu, as you would expect, and an inflection point where it stops coming down and starts going back up is exactly 1 standard deviation above and below. This is what one looks like now. Here are a few different normal distributions on the as an x-axis. They can come in many varieties. These three here, the blue, red, and orange, are all centered at 0. The mean is 0. The green one over here has a mean of -2. They don't have to have a mean of 0. They can have a mean of anything. And you can see kind of what happens as the variance increases. So our orange one here has the highest variance of 5. It's very flat. And the smallest variance we have is this blue one that's kind of stretched up like a rubber band. They come in, again, all shapes and sizes. Now, what we're going to do to get them to a manageable level is use our z distribution, or take a z-score. You remember how to do this. We take each value, x in this case, subtract it by our mean, and divide by the standard deviation. Now, once we do this, we are going to get a distribution that has a mean of 0 and a standard deviation of 1. And this is what the standard normal distribution looks like. So, as you can imagine, we're going from -3 to 3 because according to our empirical rule, 99.7%, or approximately that many values, will fall between -3 and 3. Now, it is a distribution, so the area underneath the curve should be 1. Has to be, in fact. Now, you'll see a little bit of values over here, and notice it does not dip below the axis. You can't have negative probabilities or anything like that. 0, again, being the mean, right in the middle, and 1 standard deviation above, 2 above, and 3 above, and so forth. This is what we're ultimately going to be using for calculations. Now, your calculator will be able to calculate the probability, or basically the area in between any two values. So what it takes is it takes a lower value and an upper value. So the left z-score and the right z-score. Or if you're going strictly above one value or strictly below, we're going to use E99 or -E99, which is the largest or smallest value that your calculator can handle to do that. Do that when we get into the actual usage. So second and then vars will find the distributions, and the normal CDF, cumulative distribution function, is there. This is some notation as to how you can see problems. It's either going to be in between two values, strictly greater than value, or strictly less than. Again, you can put equal to signs anywhere you want. It's not going to change the actual probabilities at all.